It is my great pleasure to introduce my friend and colleague, Jens Munnig. So Jens, lawyer, speaker, developer, guru, really for me, it's wonderful. So yeah, Jens, every time Jens is on stage, wherever conference, I'm watching it like half speed because I'm trying to take the notes. I learn so much from Jens every time I hear him speak. He's remarkable, and we're so delighted that he's the lead of this project. He's just an incredible Renaissance man, musician, and a great friend. So let's put our hands together for an outstanding keynote where we learn about Snap 7 from Jens Munnig. Woo! Wonderful.
Thank you, Dan. Thank you, everybody. Hi, welcome to Snapshot 2021. We're about to release Snap 7 finally, although we've run into some last-minute glitches that we need to investigate first, just kind of 10 minutes before this conference. But so this is really all about Show Your Project. And Snap is my project, so I'm just going to show you Snap 7. And of all the new things that are in Snap that you can already play with at the dev, at the beta, I want to show you three things, really. I'd like to show you scenes. I'd like to show you Microworlds, and I'd like to show you something that I'm referring to Parsons problems all the way down. So I'm just going to share my screen and just demo the hell out of this. How do I share the screen? Here, I share the screen. I cannot share. Can somebody let me share? Now I can share. Okay. So you should be seeing Snap 7. It's the dev version. And the first thing I want to show you really is scenes. Scenes is something that we learned from Wolfgang Slany, from Pocket Code, really. And we've had a lot of discussions with Wolfgang and the team about how they're doing it. And we've sort of adapted this concept. So with scenes, we're trying to bring to projects what we're doing with blocks for programming. So we can stick together blocks for programs. So with scenes, we want to combine projects into larger projects. So let me give you an example. So I've been working on this thing that I'm calling game, and this is about as far as I got. I made this opening screen. It says, welcome, click here. I have a score, and that's just about it. So two of my friends have also worked on parts of the game. There are little games. One is called Jump, another is called Fly. So I'll be able to mark the two of these and drag the two of these over and drop them into Snap. And now I have more icons underneath the stage here. And those are the three scenes of my project. I can do the same thing via the menu and make a new scene or add a new scene from the cloud. So the second scene is, the first scene really is a little jump and run game. And the third one is kind of where we need to fly and deliver presents for Christmas. So I want to bring these scenes together into new games. So when I click here, I want to change, I want the program to start. So I'm going to say, okay, when I am clicked, I want to switch to the next scene. And this is a new block underneath here where I switch to the next scene. And when I click on this, I'm switching to the next scene, which is going to be the opening scene, but it doesn't start. So in order to automatically start this, I can expand the switch to block and send a message. And that message can be anything, any event that the other scene responds to, but also I can send the green flag event, which is usually what I'm wanting to do. So I'm going to switch to the next scene, press the green flag. So now I'm in my friend's jump game, and the jump game basically is over. I need this character to jump and reach this goal, this target. And once it's reached it, I again would like to switch to the next scene. So I'm again going to say, okay, switch to the next scene. And I also want to, stop it. I also want to switch to the next scene and again, fire the green flag. So now I'm in my third scene. That's a little clone intensive flying game. And in this scene, I'm going to have to drop as many presents as I can into the chimneys of kids. And so I want to run this for a couple of seconds. So I'm going to wait for, let's say 20 seconds. And then I want the game to be over and look at my score. So when those 20 seconds are over, I again want to switch to the next scene, which is going to take me back to my game. But I also want to have the score in this one. So they all have the score variable, but there is no common, no shared score really. So when I send something along, I need to send the score. Now I could send the score directly, it's just a number, and probably it would work. But another practice is that we could actually wrap it into a little list where it could say, hey, the score is this. And then I'm sending this list with the score over to the next scene. Now I'm back at my kind of frame project, and I want to react to that. So in the control category, I can get when I receive. Now, there is no when I receive a list with a score in there, but I can check whether I receive any message. And watch what happens when I receive any message. I now have this little expansion arrow that I can expand, and I get a variable of what I'm being sent. So now I can ask if what I'm being sent is, in fact, if the message is a list, because if it is, I can assign to my score variable here something that is in that message, that's item 2 of the message, and I can switch to my other costume, that is the finished costume, and I'm done. So let's actually try to play this game. I'm clicking here, so I need to reach this turning gear, whatever that is, to progress to the next level. And now I'm in the next level, and I need to fly. Here's one chimney, another one. Oh, where can I? This is actually Santa. This is Rudolph trying to deliver some Christmas presents. There's a house. Oh, will it be enough? Zoom makes it slower. And I got another one. Where's another house? Okay, ta-da, my score is 3. So the idea really is to open up more ways for kids to collaborate by taking units like a project, not just sprites or blocks, by putting together projects into bigger projects. So the use case could be, help screens or chapters in a story, levels in a game. And I really just can't wait to see what people make out of this. So this is the first thing, scenes, new in Snap 7. The second thing really is something for teachers and curriculum developers. It's Microworlds. And I want to make a little new project to show you, to just build a little microworld. And, my constructionist friends will hate it because it's a computer sciencey project, and computer scientists will hate it because it's an imperative project. But whenever I talk to teachers, whenever I look at schools, I see all of you actually doing it in school. So let's do it here, maybe make it a little less terrible than it usually is done. So I want to make a little microworld that is about data. So I can make actually a new category now, make a custom category, which I'm going to call data. And I can give this a new color, like, this could be a color. I can also specify, if I right click on here, I can also specify it in RGB. So I make a new color, a new category, data, and it's empty. So I can still click it and make a block. So I'm actually going to make something that's going to call initialize data with n items. So this is something that I'm going to show to students. So I'm going to make this input. I'm going to say, okay, let's initialize the data with 20 items. And now I'll make a variable, also another variable data, and I'm going to say, okay, if I initialize the data, I'm going to set the data to the numbers 1 to n. Actually, let's try this now. So now there's a list of 20 items. And what I want to do is I just don't want to show this as a variable. I want to really visualize this on the stage. So I can import a library. And in the frequency distribution analysis library, there's a nice block plot that plots anything kind of as bars. So here's this plot block, and I can plot the data, and it'll just fit it into this rectangle. So actually, this is a little complicated to give to students. So I'm going to make another block that is just going to put it to my data category. This is going to say plot data, and it is just going to do that. And it is also just always going to clear it. So, and you know what, while I'm at it, I'm just going to put this block in here also. So whenever I initialize the data, I'm plotting it. So let's actually try this. So plotting 20 items, plotting 50 items. Yeah, it works. So I'm going to plot 20 items. I also don't need to show this the sprite, so I'm going to hide it. And I want to give another block to the students to actually that I'm just going to give to them. This is going to be the swap block. Swap items I1 and I2 in data. And I just want to give that to students. So that's going to be an input. It's going to be a number. And the second index is also going to be an input, and it's going to be a number. And I'm just going to write the usual thing in here. I'm going to make a temporary variable. Whoops. Let's spell right. I'm going to set temp to the first index. Then I'm going to replace two things. I'm going to replace the first index of data, actually going to need data here also, with the item of the second index of data. I'm going to replace the second item with temp. And while I'm at it, I want to visualize all of this. I just want to replot the data. So let's try this. So I'm swapping the items 5 and 15. Wait, should have told me that this is what I should be doing, right? Okay, let's try this. Yep, it's swapped and it's swapped back. Okay, so I can swap items in the list. And now I can go and build a little microworld. So I want students to shuffle this. So I can shuffle this. I take for I equals 1 to, let's say, length of data. Let's swap the items I and a random index between I and the length of data. Let's actually try this. Yep, it's swapped. You can click it again. So now the list is shuffled, and I want to again sort it. So I'm sorting it using the infamous bubble sort. So I say again for I equals 1 till, now since I'm going in pairs, say -1 length of data. And I'm going to check whether the item I of data is greater than the item, where is the item I plus 1 of data? And if it is, I'm again going to swap items I and item 1. Let's try this just once. So yep, this works. You can see now the largest one is at the very end. Let's try this again. So this is how it bubbles up. So now this is already sorted. I don't need to go through the whole list. So I can wrap another for loop around this and optimize this and say, okay, for I equals length data till 1. And this is actually what is ordered. And use this here. And now let's see whether it sorts or orders this whole list. Yes, this works. Let's shuffle it again. Let's do this. Fine, this is great. So now I want to give this as a little microworld to my students. And so what I can now do, and this has been really work that has been instrumental by kind of many contributors, but most of all really Michael Ball, who's worked on this thing, is we can now do certain things to this scene really to make it turn it into something interesting. We can, for example, hide all the blocks. We can hide the blocks, so we get this dialogue where we can hide anything and everything. But there's a special option. If we right-click here, we can hide all the blocks that aren't used by what's in the scripting area right now. So a lot of blocks aren't used. If I now click on this, I'm seeing there's no block in the motion category that's grayed out. There are some blocks in the control category, operators, variables. So it's now I want to show them all in a single palette. And there's this single palette option. I'm just a single palette with just a few blocks. And even there, I can compress this some more. I don't, for example, in this case, I don't want to show the categories. And I don't even need my students to ever make a variable. So I can also hide the buttons. And this is now really a microworld, like a Parsons puzzle, really. These are all the blocks you need to make this. So now I can safely delete this and give this, save it, and it's sort of my own mini language, which I can give to students, and it's a microworld that I can build these mini Parsons problems or these mini languages for domains that I like to play with. And this is a feature we're really excited about. You can configure many things in these scenes. We have basically full control over what you show in the palette. You don't, like, even now, if you, for example, use keyboard entry, you only see the blocks that you've selected, like none of the other blocks. So you can make your really very customized version of Snap. You can hide all the helper procedures and really only make blocks that you want to be, that you want to face, that you want your audience to see. So this is really the second big thing about Snap 7, microworlds and Parsons problems. Now, when I say Parsons problems all the way, this is the third thing that I want to show you. So again, I'm making a new project, and whenever I show you the, things like 3 plus 4, you probably know that I'll be talking about rings. So we have 3 plus 4, and we can, for example, find out whether 3 plus 4 equals 5 plus 2. And so, yeah, both is 7. But what if we ringify the 3 plus 4 block, and we ringify the 5 plus 2 block, and now we want to know whether the 3 plus 4 function equals the 5 plus 2 function, and that's not the case. So they're not the same. But now, new in Snap 7, if they're having the same structure, they actually equal. So this is a new thing that we can compare rings, that we compare scripts. And what makes this possible really is something that we internally, that we overloaded the split block. So we can split words by, a delimiter, but now in Snap 7, we can also split blocks. We can split rings and functions by blocks. So what we get when we split a block is we get a list starting with the empty block and followed by its inputs. So this is it's a syntactic analysis of blocks. So what if we have something that's more complicated than 3 plus 4? So let's say we have 3 plus pick random 1 to 10, and we split that by blocks. We get a tree, a syntax tree. So the new thing about this is that we can now do syntax in a blocks-based way. And we can split things like, move and turn, now a sequence of blocks. When we split that, we get a list of syntax trees, or as Brian says, a syntax tree forest. A syntax forest, actually. So we can split things, and now the opposite would be to also join things. So we can say, let's join. Actually, let's join the 3 plus 4 block. Ringify this. Make this empty. And let's join this with some inputs, so we can put the inputs back into the block, and we can call it right then. We can also embed something else, like we can embed something like put the mouse X in here. And this way we can really build our own scripts. We could say, for example, let's have the if block, if mouse down. Let's ringify that. Oops. And we want to have something like, let's show. And this way, we can construct and build our own scripts programmatically. And what we get out of this is always a function that we can run and call. So let me just show you an example of why I'm really excited about this feature. Because this is somehow, remember when Bernat told us about why we love Smalltalk so much? So this really lets us now do some of the things that we love doing in Smalltalk in Snap. So here's a project that Yetka and I've been working on. This is, you might have seen it, it's a gesture recognizer for the AI project that we've done for the Wissensfabrik in Germany. So it has a bunch of custom blocks. One, for example, is centroid. That's I guess the center of a path of points. So we have another block in Snap 7 that lets us get the attributes of a block. So this is a custom block. Its definition is, this. But I can also get the definition from this sensor block that gives me the definition of any custom block or any block. So the definition here is a ring, and it has the same, it's basically what's inside this definition. It has the same input as the definition. So I can get the innards of a definition. Now I can, of course, also split them with this new block. Not join, split. Now I'm splitting the definition by blocks. And I'm getting the syntax tree. And it's a tree. So I can actually use all the work that we did on APL and tables. I can get the, I can flatten that tree to get, now get this, the Parsons puzzle, really, all the components that are needed to make this block. So this is where I'm kind of saying this is Parsons puzzles all the way. I can get a Parsons puzzle of any block of any script that I made. So this is interesting. So what if I, you know, want to find out all the scripts in my projects. So there is the my block, and I've got two more entries. Like one is all the scripts, and you can see these are all the scripts without the hat blocks, even including my scripts that I'm just evaluating. But it can also get all the blocks. Here are all the blocks. And basically what you again get is the whole palette, all the blocks that you decided to show. So if you hide blocks in the palettes, you're also not going to see them here. So these are all the blocks. And hey, I want to do functional things with these blocks. I want to use high order functions on them. So I want to keep the blocks that contain the centroid block. So I want to know which blocks use centroid. So the block doesn't contain the block, but something else. Yeah, the flattened syntax tree of its definition. It's Parsons puzzle, whether any of the puzzle pieces is the centroid block. So I can put this in here. And now I get the result. Okay, the centroid block is used by these blocks. So this is a powerful way where we can actually make some of those debugging tools that we love from Smalltalk ourselves. So we can have colors of the block. We can make these tools, these introspection tools ourselves. So reporter. And I just want to define the colors block. And instead of the centroid, I'll make this for any block. So now I'm applying this. Here's my colors block. Can get the colors of centroid, but can also now try this with any other block. So how do I get all the custom blocks? You know, I can export all the blocks. Then I get a list of all my blocks. Also, what's new in Snap 7 is that I can take any of these blocks right out of here and use them as a palette. So I can see all the colors of some. These are some more blocks. So these are the three things that are really new in Snap 7. There's many more things. So scenes really let you build projects out of smaller projects, let you collaborate with many people. Microworlds is a new way for educators to customize a Snap experience for a certain domain or a problem. And syntax trees, syntax analysis lets us do algebra in a new way, blocks-based. I'm really excited what you'll make out of Snap 7. And once again, welcome to Snapshot 2021. Glad you're all here. I can't wait to see all your projects. Thank you very much.
Woo! Thank you so much, Jens. Thank you so much. We still have about a minute. Do you want to entertain any questions at all from the audience?
Sure.
All right. Anybody have any questions? Feel free to unmute. Feel free to share how you're going to use this in your own classrooms. If you've been inspired by this is wonderful. There's a lot of love in the chat, by the way, for how powerful these features are and how inspirational they are. Let's see.
I've got a question.
Go ahead.
So the last stuff you showed us, it seems like it's almost all the way to having some kind of macros. Is that the right way to think about it?
Yeah, it's some way towards macros. Yep. The idea is to, yeah, embark on macros for maybe Snap 8.
Hi, everybody. Hey, Jens, tell me about that scene where you were Santa Claus flying over the terrain and the houses that looked very three-dimensional.
Yeah.
How did that, how'd you do that?
It's actually funny. It's really easy. I mean, you can just make sprites bigger and smaller, and you can tweak the sizes and the positions. It's really just that. It's what you call 3.5D, I think.
Oh,
it's
maybe
really
the
just
2.5.
2.5, right? Sorry. Yeah. Basically, yeah. It's tricking with perspective.
Cool.
Yeah.
Yeah, it looks great.
So, thank you. I mean, it's like you can do the thing moving sideways. It's easier. It's just kind of parallax. You just make things that are make things smaller if they're kind of more up on the y-axis, and you make them bigger when they're down, and you make them come to front when they're kind of more down. And yeah, and then there's some waypoint perspective. Actually, there's since Dan mentioned it, there's an artist who found out all about it in the 16th century by the name of Alberti, who happens to be the same one who invented cryptography in the West. And he wrote books about it and made real fun drawings about how that works. So yeah, you can do many things using 2D. Thank you.
Great, thanks.
One question.
We're at time. Let's thank Jens once again and give ourselves a little bit of break, and we'll come back at 9:45 Pacific, 12:45, and I forget what time that is in Central, in European time. But thank you again, Jens. Woo!
Thank you, everybody.
Wonderful.